All right. Good evening, ladies and gentlemen. Welcome to the Calgary Python Meetup plus the Edmonton Python Meetup plus the PyData Meetup. So it's a 3 meetup across Alberta, and we're thrilled to have you all here tonight. Here are at the bottom are some Slack workspace and Twitters and websites that you can visit. And I would like to thank Startup Edmonton for the collaboration, which allows us to use the wonderful remote platform. And also the Viewpoint investment partners for the PyData. Excuse me. Some jobs information here. So first one is a senior software engineer at the Cortec AI and also CDO, some jobbers. And there are lots of positions at TechnoLogic, and there is a software engineer position at the Viewpoint. So today's talk, we will have Meredydd give us a talk on the Anvil, the full stack web with nothing but Python. So it's a really good one, and I'm really looking forward to that. For some upcoming events, nowadays they're all online, so feel free to check it out online at the python.org/events. And also, we had the news actually was announced last time as well. The PyData is proud member of PyYYC Data Society, so feel free to check it out. Some news. It's a little bit slow, I think, compared to last month, that we only have about 2 news. So the Python 3.10 beta release. There's a little bit new minor version for that, and we have another security release for various Django versions. Readings for the month. For this month, I picked some of the articles which have pretty fun projects that you can work on. For example, the smart kitchen or like smart home or whatever. The first one is the how to modernize your kitchen with QR codes in Python. So this package is called the QR code. This library, you can use it to generate a QR code image and use it everywhere. The second one is how to easily convert the Python script to an executable file, which is the exe that you can use on Windows machines. So in this article, it shows the Autopy to exe and PyInstaller. I actually use the PyInstaller a lot, and it's pretty easy to use. And I think there's another one called like Py to exe. So without the auto, and they're pretty much all the same. The third one is 5 tasks to automate with Python. So basically, it's the auto reading for like the text, and the weather reporting, currency converter, sorting downloads folder, and some morning setup. It's pretty fun. The last one is PyTorch versus TensorFlow in 2021. A comparison between the 1.8 of PyTorch and 2.5 TensorFlow. So, well, a couple years back, we used TensorFlow a lot. But nowadays, I think PyTorch has taken up the majority of, well, I would say academic. And maybe it starts shifting towards the industry, but I'm not entirely sure. Well, this is an article you can take a look at. It's the author's opinion in this article. So, yeah. At last, we always have the stats that you can take a look. And the next meetup is July 28th. We're always looking for presenters, any topic, any experience levels, whether it's demo or it's a presentation. Just feel free to reach out to any of us. And now let me actually introduce our speaker, Meredydd. So he is one of the original creators of the Anvil web framework. He learned to program with QBasic and still misses the accessible on-ramp into programming. He did his PhD in the building usable programming systems and has worked on projects from messaging apps to the Linux kernel. So he's based in Cambridge. And in his spare time, you can find him dancing, and flying an airplane, which is pretty fantastic. These days, he enjoyed the rich social life of starting outgoing boxes and talking to people who aren't there. So let's welcome him.
There we go. Am I with you?
Yes, you are.
Excellent. All right. So hello. Thank you very much for having me. My name is Meredydd, and as advertised, I'm here to talk about building full-stack web applications with nothing but Python and the Anvil framework we built to do it. So this is
I think you were accidentally muted.
how's that?
Are
we better?
Yes, you're
Yep,
back.
there we go. I hit the hotkey to advance the next slide and muted myself instead. Let's try this again.
All right.
Hello, my name is Meredydd. I'm going to be talking to you about a framework for building full-stack web applications entirely in Python. So that includes Python in the web browser, Python running on the server, even a Python user interface toolkit. And the first question that you might reasonably have about this is why? Why are we bothering? And to answer that question, really, we need to start by talking about the web as an application development platform. Because I would contend that the web is a pretty developer-hostile environment. And to think through why, let's imagine a typical web application from the perspective of a piece of your data. So if you're building a web application, you start with your data as rows in a database table, typically accessed by SQL. But of course, it's not going to stay there. You will immediately extract it and transform it into objects on in your server code, probably Python objects in present company, accessed by methods and attributes. And then you will immediately turn around and represent those objects as JSON accessed over HTTP endpoints with this weirdly limited set of verbs like get, post, put, delete. But of course, on the other end of that HTTP request is a piece of JavaScript code which will reassemble that data into its own objects with its own methods and its own attributes. And then render those into HTML DOM with its own APIs and use CSS to turn those into pixels. And that is a lot of different representations of your data. And indeed, the day-to-day work of web development is mostly converting your data, translating it between these different representations. And that's a problem because it attracts the wrong kind of magic. Let's take a totally unfair pot shot at SQLAlchemy, which is actually, it's a really cool library. It automates the conversion between rows in an SQL database and Python objects. So instead of having to write SQL code like this to select rows from a table called books, you can write Python code like this. So query filter book.price is less than 20. Well, that's nice. Lets us stay in Python. But of course, the process of turning this statement into SQL we can execute against a database is black magic. We're talking meta-classes. We are talking overriding innocent Python operators to do something completely different to what they normally do. And if you poke it too hard, you will find that out. So if you try to treat book.price is less than 20 as if it were an ordinary numerical comparison, you're going to come unstuck. And you're going to have to understand that that is in fact an overloaded operator returning some kind of custom object that SQLAlchemy will then use to generate SQL. Which means to use this library, this layer of abstraction successfully, you're going to need to know Python, and you'll need to know SQL, and you'll need to know how SQLAlchemy does the translation. So we've made a sort of devil's bargain. We've had to learn a lot more and deal with a lot more complexity and a lot more moving parts in exchange for which we get faster writing of our code because we can keep it all in Python and we have a bunch of extra facilities. And this bargain is perfectly legitimate. You can get away with it completely if you do it once. But of course, that's not what we do. We've got ORMs helping us translate database tables into objects. We've got REST frameworks helping us express those objects on HTTP endpoints. We've got JavaScript frameworks like Angular's resources helping us reassemble those objects into JavaScript. We've got templating engines like React helping us transform those objects into HTML DOM, or possibly Jinja 2, or possibly both in the same application. We've got CSS frameworks like Bootstrap helping us translate that HTML DOM into pixels. And all of these are that same leaky abstraction. They're all abusing one of these representations to kind of sort of represent one of the other representations. And that means that to use this platform effectively, you need to know everything in the blue boxes and everything in the orange boxes to get anything done at all. We're Pythonistas here. How does that stack up against PEP20, the Zen of Python? Simple is better than complex. I mean, that was not a simple system. There are so many moving parts, and the more frameworks you have, the more moving parts there are. Here's another one. If the implementation is hard to explain, it's a bad idea. Well, the inside of a JavaScript framework is famously gnarly. You're really going to have, again, you have to learn an awful lot to understand what's going on under the hood, which you'll need to do in order to debug it when it breaks. Here's a famous one. There should be one and preferably only one way to do it. Do I need to say more here? Frankly, the ecosystem is a mess. And we took a look at it and asked, well, could we do better than this? And looking at this stack of representations and frameworks, it was clear that just writing a better web framework wasn't actually going to help very much. Because if you swap out one of those orange boxes for a new, better designed orange box, the fundamental problem still remains. You're still dealing with all these representations and all these, just the sheer quantity of different frameworks and the conceptual gaps they're bridging. You're still going to give people a bad day. So what we thought was, well, if we really want to solve this problem, let's get rid of all these different transformations and keep everything in one representation. And the representation we chose was the Python programming language. So we built a web framework where literally everything is in Python. So that's a user interface toolkit built in Python, a mechanism for running Python in the web browser. So now, to drive your user interface, you don't have to generate source code in a different programming language and have it styled by a third programming language just to get pixels on the screen. No, you're just manipulating Python objects. Python on the server, of course, but now we're running Python on the client and Python on the server. We don't need to mash all our data into JSON to get it from one to the other. We can just make a function call. We even built a Python native database where the database rows have Python object semantics. And what that means is that you can take a row of data from your database and you can pass it all the way to the front end of your application without changing its representation. And what that means is that you can build stuff really quite remarkably quickly and easily. But that's the theory. Let me show you how that works in practice. All right. So here I am in the Anvil editor. And I'm going to show you how this framework works by building an application, just as an example. So It's going to be a sort of hello world type application. This here is a web page. And this here is a toolbox of things I can put onto that web page. So if I want to, for example, put a title on my page, I take a label component, I drag and drop it up to the title bar, and then I change its text property to go hello PyYYC. So that's how I put some text on my page. Okay, let's make it a little bit more interactive. I'm going to put a card on here, and I'm going to prompt the user to enter their name. And then we can greet them by name. So we'll want a label for the prompt. We'll have an input, text box for them to answer that question. I'm going to call this name box. So everything in Anvil has a variable name, so we can access it from code. We're going to have a button that they can click when they're done. I think it's a bit more prominent. And you can see what's going to happen here, right? They're going to enter their name, they're going to click the button, and we want to display a message. So the final thing we need is a label for that message to appear on. I'm going to call it message label. And we can change some other text properties. So we can make it centered, and we can make the font big, and so on. So now I've just built a UI. And obviously, that's an awful lot faster than it would have been in HTML or CSS. But the really cool thing is this is all backed by Python. So if I double click this button, I am now editing the Python code that runs when that button gets clicked. And all the things I dragged and dropped onto my page are available as objects in my Python code. So if I want to update the text on the message label based on the text in the name box, I can go self.messagelabel.text equals hello self.namebox.text. And that's it. So if I run this now, enter a name. So that's working. This is an interactive web application built with nothing but Python. It's now actually already online. Okay, so if you go to hello-alberta.anvil.app, this application is already live and on the internet. So we've just built and deployed a web application with nothing but Python in an incredibly short amount of time. Now, actually, everything we've been doing so far has been running in the browser. So this Python code gets compiled to JavaScript and runs in your browser when you visit the app. This is good for fast responses, obviously, but any serious application is going to need some server-side code as well. So let's add a server module. This is a Python module that runs on the server. We host it for you, manage the infrastructure by default. Perfectly ordinary Python function module, perfectly ordinary Python function. But what I can do is I can tag this function at anvil.server.callable. And that says that this function on the server should be callable from the browser. So let's go back to the browser code. When the button gets clicked, we update the UI, and we also go anvil.server.call. We call the say hello function. We know it takes one argument, the name. So let's pass in the text from the name box. And now when I call this, you can see I've got some output in the logs. And that was that print statement running on the server. And now we're properly in business because, sure, there's limits to what you can do here. Not everything is going to be able to compile to JavaScript. You can't access files and so on. But this is a real CPython environment. You want to connect to a database? Import CycloPG2. Go. You want to do some machine learning? Import TensorFlow, or maybe PyTorch. Maybe read that article from earlier. You want to do some statistics? Import SciPy. Whatever it is you need, this is a real Python interpreter, and we can drive it from that UI we've built with nothing but Python. In practice, the first thing everybody asks is, well, how do I set up a database? So we actually have a database built in. It's called the Data Table Service. It's backed by Postgres, so you can happily store gigabytes in this thing if you need to. I'm going to be a little bit less ambitious. I'm just going to store all the names that get entered. So we've got a table called visitors. We've got a text column for the name that gets entered. We've got a date and time column for when that was entered. And that's it. I've just built the database. This table is called apptables.visitors, and we can access it from code, just like we could access those text boxes and labels and so on. So let's go to our server code. When this function gets called, as well as logging that message, we can take apptables.visitors and we can add a row. We can fill out the name column with the name that's been passed in. We can fill out the when column with datetime.now, which I need to import. And now when I run this application, if we go back to the database, we can see that those names have been added. So I've just built and deployed a database-backed web application with nothing but Python in a very short period of time. And if anyone thinks I'm faking this, a reminder that this is available at hello-alberta.anvil.app right now, and you can prove that I'm not. Just going to take one sip of water. All right, so I have one more thing to show you before we go behind the scenes and I start talking about how all this works. And that is displaying some data on the page. So to do that, obviously we're going to need some way of getting that data. So I'm going to add a server function here. It's a callable function, get visitors, and it's going to return apptables.visitors.search. So that's going to return a lazy iterator over the database, or over that table rather. And now let's go into the client code and give ourselves somewhere to display it. So I'll have another card here. I'm going to add a data grid to that card. And we can set up some columns. So there's going to be a column for the name, which is going to pull the name key out of each item. We have a column for when, which is going to pull the when key out of that item. And we don't need this third column at all. OK, we can drag to resize this. Now, OK, so we've got our data grid. Inside our data grid is a component called a repeating panel. And this is a component with a property called items. And you can set this to anything, any iterable Python object. And what it will do is that it will iterate over that object and it will instantiate this chunk of user interface for every element in that iterator. So all we need to do is set the items property to an iterator over our table. So here we are in the constructor for this method, and we've set the repeating panel 1's items property to the return value of the getVisitors function. Easy peasy. Let's run this. Oh, look at this. Yes, we have some data. And you can see that we've just pulled some data from the database and we're displaying it. One more thing. This isn't quite looking how we'd like it because this column's looking a little bit ugly. You can see what's happened, right? We've got a date time and we've just called stir on it because that's reasonable default behavior for display this object. But let's try to format that date a little bit better. So rather than the default behavior, what I'm going to do is go and edit the template for this row. And instead of the default behavior, I'm going to put a label in here. And I'm going to add a data binding so that the text property of that label gets set to this Python expression. And in this context, self.item is a row from the visitors table. It's an element from that iterator. And so I can use square bracket notation to get the when value, which is a date time. And of course, it's a Python datetime object, so I can just call stir of timer. %y. All right. So now when we run this, we're seeing some nicely formatted dates. So again, built and deployed a database-backed web application with reads and writes in nothing but Python in a very short period of time. So that is what the framework looks like to use. So I'm now going to spend the rest of this talk talking about how it works behind the scenes. The first thing I should say, of course, is that although you see me using a hosted service with everything out of the box, this is an open source framework. So if there's anything you want to know that I don't cover in enough detail, just head over to GitHub or check it out, or just pip install it locally and try it for yourself. Okay, so I'm going to take a little wander through some of the many things I could talk about how this framework works. Let's start with an obvious one, compiling Python to JavaScript, because that's a fairly important thing to be doing. If you are writing a web application entirely in Python and you want it to run in a web browser, well, the browser only understands JavaScript, and so you need to be able to translate from one to the other. And for this, we use a project called Sculpt, which is a Python to JavaScript compiler. You feed it a string containing some Python code, and it will produce some JavaScript code that has that same effect. You feed it a Python function, it will produce, honestly, the ugliest JavaScript function you have ever seen, but it will have the same behavior as that Python function. Now, this is a project that already existed before we wrote Anvil, but I'd like to talk to tell you the story of the first major change I made to Sculpt, which is about blocking versus non-blocking code. Because JavaScript, in its infinite wisdom, is a 100% non-blocking language, which is to say that every function, every piece of code has to complete before the browser can become interactive again. And that's not great when what you're trying to provide is an idiomatic Python experience, because an idiomatic Python API tends to look a little bit more like this. You call something, get a return value, and then do something with it. Now, even with the arrival of async await, most Python APIs, certainly the ones that you will encounter as a beginner, look more like this. Whereas the JavaScript APIs work more like this. That's 1, 2, 3 nested callbacks, because you have to have some sort of break in execution and then a callback whenever a blocking I/O operation occurs in JavaScript. Now, this isn't entirely fair. This was actually copied and pasted from the first page of the Postgres JavaScript API documentation, but that was a couple of years ago. These days, people in JavaScript land use promises and async await to help abstract over the difficulty, but that abstraction is just like the abstractions we were talking about with web frameworks, which is to say that, sure, they work, but to understand what your async await code is going to be doing, you need to understand that it's actually promises underneath. And to understand what promises are doing, you need to understand that it's just function callbacks underneath. So again, to use this abstraction effectively, you need to understand how the syntactic sugar works and also what it translates to underneath. Now, this isn't really an experience we want, but we have a Python to JavaScript compiler available. What if we could translate this into this automatically? So we check out the source code and start exploring. It turns out that Sculpt has a classic compiler architecture based, unsurprisingly, on CPython. So when you compile a Python expression or a chunk of Python code, it will go through the same pipeline as CPython. So it will first tokenize your code. So that's it will split it up into a set of short strings with meaning for Python. By the way, these .js files are the source files in the Sculpt repository if you want to follow along. So you split this up into tokens, and the next thing you will do is you parse it, and that will produce something called an abstract syntax tree, or AST. And this is a tree representation of the operations that Python thinks of. So here we have an assignment, and we are assigning to a variable named result. The value we're assigning is the result of a function call, the calling a function named f with an argument that is the numerical constant 42. And then what we have is a compiler that grovels over this tree, spitting out JavaScript. So that's the basic compiler structure. And of course, if we want to translate blocking Python into non-blocking JavaScript, it's this part that we're going to have to modify. And so what we did was we invented a new return type, because remember that if this is JavaScript, every function invocation has to exit. So your function has to return no matter what, even if it's blocking. So what we invented was a new return type that the function could return to say, I'm returning, but I'm not really done, I'm just blocking. And we call that a suspension. And so we compile code like this into something like this. So we call the f function, and then we look at the return value. And if it's a suspension, then we save the state of the currently executing function as our own suspension and return that. Here's how that works in practice. So here we've got a somewhat idiomatic piece of code. The call stack looks like this. So the Anvil runtime that's handling the user interface library has called the button one click function, which has called the get method on that database table, which has gone to the database, and the database has just blocked. And so to signal that it's blocked, the database code returns a suspension. The get method checks the return value and realizes it's been given a suspension. So it saves the value of all its local variables, it saves all its temporaries, it saves where it is in the function, and then it stores all of those in another suspension that includes the original one. And then button one click does the same thing. It realizes it's been given a suspension, so it saves its locals, saves its temporaries, saves where it is in the function, and returns the suspension to the JavaScript runtime. Now, a few milliseconds later, the database gets back to us, and we can reverse this process. So the runtime spots that in fact, it's a JavaScript promise that's been resolved, and resumes the suspension. And what this is, it's a special way of calling the button one click function. So you call that same generated JavaScript function, but passing it as a suspension and saying, I'm calling you, but this isn't from scratch. I want you to resume from where you left off when you gave me this suspension. And so button one clicks, generated code, it will restore its local variables, it will restore its temporaries, it will jump back to the right place in the function, and then it will resume the inner suspension, which will restore its locals, restore its temporaries, jump back to the right place in the function, and resume the innermost suspension from the database. And that resumption can just return because we are back in, we have some data now. And now we've reinflated our call stack and we're back to normal execution. And that is how Sculpt converts blocking idiomatic Python into non-blocking JavaScript so that you don't have to. If you want to know more, you can check out the project at sculpt.org. I am one of the maintainers, at least after that change I was. And we're always looking for more contributors, so please do come and check us out if you think that's cool. All right. Here's another topic that is pretty important to the framework that you've just seen. And that is making function calls from the browser to the server. These Anvil.server.calls they act like Python function calls. You've got the name of the function, you've got positional arguments, you've got keyword arguments, you've got return values. And when you make a call like this, it actually goes over WebSockets using a remote procedure call system. The arguments and the return values are encoded as JSON. which is fine for the values you're seeing over here. But what about the values that don't fit neatly into JSON? Like, for example, in that demo earlier, you saw me casually tossing around objects from the database and returning them from server code to client code. Now, this is obviously an API we want, but how do we do it? So as well as the JSONable data, Anvil also supports a few other portable types, and you can actually define your own. So if you have a class like this, so effectively a data class, you can tag it at anvil.server.portableClass, and that will tell the Anvil serializer that when you're sending one of these things to or from the server, it will record what type you sent, and then it will record the contents of that object. By default, it will send that object's dictionary, which contains instance attributes like weight and temp here. But if you want to get more advanced, you can control this yourself. You can implement dunder serialize and dunder deserialize methods that return then something that can be encoded into JSON and go over the wire. So we can use this to implement a system that can take a row from a database and return it through server code and return that same object up to client code and then call methods on it. In this case, it's the dunder get item square bracket lookup. But still, that person there is a Python object that is a live representation of that database row. But this is only half the story. That gets the data around, but just because you can sometimes return some database rows to the client doesn't mean that the client, which remember is untrusted code, doesn't mean that the client should be able to do anything to any database row. We need some sort of security. And so for this, we implemented a capability system. The academic definition is it's an unforgeable token. The practical meaning is if you've got it, you can use it. So the idea here is that if the trusted server code has returned an object to the client, well, then the client has access to it because it was legitimately given it. But the client can't just make up a request out of thin air for some database row that it hasn't been given. And the way we do this is we record the identity of an object and some permissions. And then we sign that with a digital signature using a key that only the server knows. And so what that means is that when the client requests to perform an operation on, for example, a database row, it passes the capability to the server and we can check the signature. And if it has a valid signature for that row, that identity with those permissions, then we must have given it that capability sometime during this session. So we know that it's a valid request and we can do what it says. You can, of course, construct these yourself as well. So here we are constructing a capability object for scoped to the database and then table ID 42 and row ID 12, and the access is read-only. And if we get past one of those objects into server code, we can validate it and say, yes, it is genuine, and this is the scope. This is the identity and permissions that it was created with. And if that's genuine, then we can trust it because we must have given it to the client for it to have come through. So what that means is we can do things like this. So here is a piece of code that is get person function, getting somebody by name, and the first thing it does is it checks whether anvil.users.getUser is not none. So it checks whether the user is currently logged in using Anvil's built-in user authentication, which I haven't talked about. I don't have time to talk about today. It's great. Look it up in the docs. But if the user is logged in, then and only then will it return a row from the data table. And that means that because that row contains a capability, the decision about whether to grant the client permission to access this row happens at exactly the same time as the decision about whether to send the data in the first place, which means that you don't have the sort of left hand not knowing what the right hand is doing. The one if statement, the idiomatic Python, does both. And so we then get to do things like this. We can use the return value and call some methods on it. All right, that's a good start. We can do some more exciting things. We can change permissions. So here, it's the same getPerson function, but this time we take a client-writable view of the people table and search that instead. And what that means is that the row that comes back has client-writable permissions set. And with that capability, we can perform updates on that database row. And now you're really cooking with gas, because the client-side code can now update some of the database rows securely, which means that you can do things like updating your database from your button-click handler code, which again makes building these applications much, much faster, because you don't have to plumb every operation all the way up and all the way down your stack. We can go even further than that. We can return whole views on a table. So, okay, here's an example database. So we've got a table of records, and every record is linked to a user's row for which user owns that record. And we want the client to be able to access only the rows where the owner is the currently logged in user. So what we can do is this. So this is the getMyRecords function. It checks whether the user is logged in, and then it returns a client-writable view of the records table, restricted such that the owner column must be equal to this user, the currently logged in user. And what that returns is a portable object that acts like a table. You can search it. You can add rows to it. You can delete things from it. But all those operations are limited to only rows where the owner column matches the currently logged in user. And so we can delegate an enormous amount of logic out to the client side safely and idiomatically. All right, so for the last thing, I want to depart a little bit from the framework, because everything I've been talking about so far is part of how the framework itself works. And I'm going to finish by talking a little bit about the development environment you saw me using. And specifically about autocompletion. Now, if you're building a developer tool, autocompletion is very important. It gives you discoverability. It allows you to see what is in an API without having to page through the documentation. It gives you speed, because everything goes faster if you can type a few characters and hit tab. It gives you confidence that what you're doing is right, because there are whole classes of bugs you can discover and fix without ever hitting the run button, because the autocompleter has warned you that this variable wasn't what you thought it was. And for all of these reasons, it just feels good to use. Now, this is probably not news to anybody who's already using PyCharm or VS Code, but if you are a die-hard Vim or Emacs person, don't worry, there is hope for you too. You can get things like Jedi as a plugin for basically any text editor. So if you still are living without autocomplete and you remember nothing else from this talk, do me a favor, try autocomplete for a week, install Jedi as a plugin, you'll be amazed. However, unfortunately, Jedi wasn't something we could use out of the box. The first reason is that Anvil is full stack. So you've seen it. The autocompleter wants to know about your data tables. It wants to know about what's in your server code. It wants to know about what's in your drag and drop UI builder. Now, okay, that itself is probably surmountable. We could probably have patched Jedi to support those things. But the real killer is that Jedi is expecting a file system, which means it needs to run on the server. And when you are typing code and hit the tab key, there's just not enough time to go back to the server from the browser, which is where the Anvil editor is. There's not enough time to go back to the server, do the completion, return the results, and then display them. If you've ever used REPL.it, which is a really cool online code editor and sandbox running environment, their Python autocomplete uses something like Jedi on the server, and it really shows because there's just like a couple of 100 milliseconds between hitting tab and choosing things, and it feels like walking through molasses. So for all these reasons, we realized we needed to build our own autocompletion in the browser in JavaScript, which is a fairly tall order. But of course, we have a Python to JavaScript compiler already knocking around. And we've already seen how the Sculpt front end works to parse Python code from text into a tree of objects that is more easily comprehensible. So this is exactly what we do. When you hit tab in the Anvil editor, what we do is we replace your cursor with a special magic symbol, and then we feed that whole module to the Sculpt parser, and we get the abstract syntax tree back. And then we can walk over that abstract syntax tree, building up an idea of what is, for example, what variables are in scope at any given point. So we walk over this tree, we see, okay, we're in a function called button1click. Well, this has arguments called self and event args. Those variables are in scope now. We've got an assignment. We're assigning to a variable named x. Well, okay, there's a local variable called x in scope now. We have a call. What's the argument? Oh, that's the magic cursor symbol. But now we know what's in scope, so we can offer them all to you as autocompletion options. The same principle, obviously, we can use for much more complicated expressions. We're not restricted to just autocompleting which variables are in scope. So you've got expressions like this. So here we are autocompleting which columns are available in a database row. But to get there, we've actually had to work out what type do we get when we take app tables and we get the users attribute. And then we get the search attribute from that. And then we call that as a function. What type does that return? And then, okay, what do we get if we iterate over that type? And then what options are available for item lookups? But again, if you just walk over the tree methodically, you can work all this information out. We can autocomplete quite a lot about Python. And as you've seen here with the database, this means that you really can collect information over the whole stack. So for example, when you make a call to a server function, we know what type you have passed in there. And what we do actually is, as the autocompleter parses that anvil.server.call, it records, oh, hey, this is a call to the say hello function, and this is the type of its argument. And so later, when you are editing your server module and we are parsing the server function for autocomplete, we can go, aha, this is a server function called say hello. I know what arguments that's called with. And so we can grab those types and we stick them into the local scope and they autocomplete. And what this means is that you can do full stack autocompletion. Even if you're using something extremely sophisticated like PyCharm or VS Code, what you're doing is you're effectively writing probably 3 different programs talking to each other. So you've got your Python code that's, its return value, the return values from the SQL queries are kind of opaque, that it can't autocomplete what columns are available. That would mean parsing SQL. And when you're in JavaScript and you've just got a result back from an API, your front-end IDE has no clue what's on the other end of that. It's Turing hard to work out what data that API endpoint will give you. But by having everything in one programming language, in one representation, and having these calls just be function calls, we can infer types, and we can autocomplete between client and server, and from the database all the way to the client. And this, again, enables us to get back to the sort of assistance that autocomplete was supposed to give us all along. We can autocomplete really quite a lot about a Python object, which leads to a rather philosophical discussion about what exactly is a type. Now, you could say that the type of an object is its Python class. But Python is, of course, a very dynamic language. You can add extra attributes to individual instances of a particular class. Heck, even two different instances with no funny business with attributes might be meaningfully different. As far as we're concerned, these two instances of the dict class are two different types. So we can, obviously they will share a lot of their implementation, but if we track them as two different types, then we can offer useful autocompletion like this. So we duck type our autocompleter. All the types are ad hoc, and that lets us do a whole bunch of powerful stuff that autocompleters that are bound to thinking of everything in terms of Python classes can't do. All right. So I've talked to you about why the web is difficult to program as a platform. I've shown you how Anvil attempts to solve that problem, and then I've gone behind the scenes and I've shown you some of the implementation details of how we make that happen. And to finish up, I would like to talk just a little bit about the design philosophy that motivates everything you've been seeing this evening. And there are two big principles I would like to talk about. The first is that code is good. We are telling a computer what to do. And in the 3/4 of a century we have spent telling computers what to do, nobody has really come up with a better way of doing it than writing text in a programming language. And periodically, people will come along and say, oh, web development, that's so hard. Here's a system where you can build applications by dragging and dropping a flowchart without writing any code at all. And that is a false promise. Anytime you're trying to build applications without writing code, you're either going to hit something that the creator of that system didn't anticipate, and you're going to hit it really soon, and you're going to be completely unable to make progress, or you're going to be tied up in Cthulhu's own flowchart, having to do at least as much computational thinking as would have been involved in writing the code. And if you know anything about programming at this point, you will be throwing your monitor out of the window, screaming, let me write the bloody for loop. So we let you write the for loop. Get you to the code. Even in the user interface, you remember in the example earlier when I was formatting those dates in the guest book. I wasn't dragging and dropping some visual noodle from the database to that user interface designer. No, I wrote a Python expression. And because I was writing a Python expression, when I wanted to format a date, I could just reach for the Python standard library and use strf time. Code is good. Get me to the code. The second, and possibly the most important principle here, is accessibility. And if I asked 3 random programmers what it means to be accessible, I'd probably get an answer something like, be simple enough for novices to pick up and use. And those people would be right. It is frankly embarrassing that the greatest application delivery platform on earth, which is the web, needs you to know 5 different programming languages and 5 different frameworks to get out of bed. It should be simple enough for novices to use, absolutely. But on its own, that's not enough. If you build something that is sort of big and soft and has no sharp edges, but it's basically a toy, then what you've done is you've taken the novices and you've shut them in a playpen. And this does the novices a disservice because they need space to grow their powers. They need to be able to learn and grow and build. And today's novices are tomorrow's intermediates, are next week's advanced programmers. So you need to give them space to grow. But it also does a disservice to the professional developers, because just because I can write 5 different programming languages doesn't mean I want to, and it doesn't mean any of my users want to wait for me to do it. And for both of those reasons, if you want something to be properly accessible, it can't just be simple enough for novices. It's also got to be powerful enough for seasoned professionals. And you might look at those two and think, yes, that's a noble sentiment, but those are incompatible goals. You can't really be simple enough for the novices and powerful enough for seasoned professionals. And if you're thinking that right now, I would ask you to look at your text editor. What programming language are you writing? We are all here because of Python. Now, Python is the language that you show to an 8-year-old when they are first starting to code on their first Raspberry Pi. And Python is the language that powers Instagram. It powers all sorts of ridiculousness in AI. It is possible to be simple enough for novices and powerful enough for seasoned professionals. We know because Python does it. And so we should know it's possible. And it's only the garbage fire of modern web development that ever makes us doubt it. Thank you very much. All right. There we go. We're coming back.
Cool. Yeah. Thanks a lot for the great talk. It was super impressive. Now, we have a couple questions in the QA channel. So first of all, how is Anvil different from Dash Enterprise?
Oh, okay. So a couple of reasons here. So Dash is a locally executing program, so it hasn't solved any of your deployment problems. Usually it's got some kind of global state, so it's really meant to be used by one. It's certainly its default configuration meant to be used by one browser session at a time. So it's great for either sort of static dashboards or for when you're using it in a single user environment, but it's not really set up for proper interactive applications. Dash is, as its name would suggest, it's mostly a dashboarding tool. And Anvil Dash is a dashboarding tool with a bunch of extra features that make it kind of useful in other environments. Anvil is an application development framework that happens to be simple enough that you can use it for dashboards. That's an important difference.
That's good. So who is this tool best aimed at? And what are the limitations and drawbacks for this tool?
Oh, right. Okay, yes. So who it's aimed for? I mean, this is a very difficult question to answer because this is a programming tool, right? And if you do that right, it is useful for everything or nothing. So everything I'm going to be saying here is going to be a generalization because people are using it for all sorts. Nevertheless, the biggest groups of people we see are, for one, data scientists, because data scientists have this pervasive problem where you have been asked a question, you have answered that question, probably in a Jupyter notebook or something, and now you can't share that question answering machine with whoever's asking it from you. We get anecdotes that you'll probably be familiar with of, oh, hey, I've solved this image processing problem. I've given the demo to, let's say, the scientists who are looking for some kind of new cellular assay that's using image recognition. And they say, that's great. That does just what we need. When can we use it? And you go, oh, I don't know. because that now you're blocking on the web development team to actually turn that into something that anybody else apart from you can use. And what Anvil does is it puts that power in your hands and says that as a data scientist, you can pick up and build an interactive application that anybody can use, and it can be a full-fledged application. So you've got the data scientists. You've got the people building internal tools. So lots of software is never really meant to be used outside the company where it was developed. So an example I love using. There's a TV network in Norway that moved from cable to IPTV. So your box is just connected to the internet. And when you're using a system like that, if your TV isn't working, you phone up customer support and you say, hey, this isn't working, and they're supposed to help you. Now, what the customer service rep needs to do to help you is to work out what's going wrong, which means that they need to be able to access information about what the TV broadcast system is doing and what it's complaining about, whether there are diagnostics from your set-top box. And that whole system needs to be built by broadcast engineers, not by generic web developers. They need to really understand how IPTV works. But the average broadcast engineer can speak a little bit of Python. And so the head of that engineering team was able to build the application to expose that information to the customer service team himself, without having to pull in a web developer to create something that the customer service people could use. So that kind of internal tooling we also see a lot used a lot with Anvil. And a lot of the people doing that are people who they're not professionally web developers, they are professionally something else. And it's precisely that something else that they need to be able to put in front of somebody else. Another common one of this is, some financial experts. If you are a quantitative analyst, you didn't invest years of your career in learning sort of React and Redux and web frameworks and so on. No, you spent your years doing advanced mathematics and finance. But you still want to be able to put those decision tools at the fingertips of the traders. And building things with Anvil is a great way to do that. So the final set of people are people building a brand new product. So often B2B applications, but a bunch of B2C as well. Actually, a few months ago in the New York Times, there was a feature on a company called Fairshake, it's really cool, actually. So you know how big companies, generally speaking, screw you over, and then there's very little you can do about it because it's not like you can sue over, the $200 they overcharged you on your cable bill, and the law, certainly in the United States, is rather fixed, so you can't even do a class action against them anymore. You have to go into their private court system. But Fairshake realized that they could make the process of representing you in that dispute resolution process so simple and automatable that it actually makes sense for them to take on cases for $200. And they built this whole consumer-facing application that lets you make these claims and lets them assist you in actually engaging in the dispute resolution process. And suddenly now you have negotiating leverage, and you can get a refund or other compensation from from whatever big company has done you wrong. And all of that runs through a consumer web application, mobile first, built with Anvil. So that was a long answer because you asked me a really big question. The three biggest groups are data scientists, people building internal tools, and people building new products. But even that probably hasn't captured them all.
That's a really great explanation. So I was wondering, since you were talking about the computer science, the CV, computer vision stuff, I wonder, just curious, does it support, the embedded view of a camera or that kind of stuff?
Right. So yes, this is an excellent question. It's an instance of a much larger class of questions, which is, does it do such and such, where such and such is some piece of the browser's API that, let's be honest, the browser programming surface is gigantic and getting bigger every week. There is no way that we can expect to provide a good Pythonic API for everything a browser could possibly do and everything it will be able to do next week. So what we've done instead is implement pervasive escape hatches everywhere. So in the particular case of using the embedded camera stuff, no, we don't have that off the shelf. So what you will have to interact with the JavaScript API for doing that. And the way you do that is from anvil.js.window import the object name. And you can drive JavaScript objects from Python. And then once you've done the usually about 2 or 3 lines of interacting with the JavaScript API, you go, okay, so now I'm getting the image snapshot from that. I'm going to convert that from the utility function, convert that from a JavaScript blob or uint array into an Anvil media object. And now I'm back in Python.
I see. So it's more like a bridge between the Python.
Yeah, exactly. There is a bridge. And once you've built that, you can even package it up as a custom component that other people could use. So you could build here is how to take a picture with the embedded camera viewport as a custom component that somebody else could then add to their app, and then it will appear in their toolbox and they can drop it onto their screen, use it like any other component. So we didn't want to set ourselves up so that we had to be complete, so that we had to cover every base. What we do is offer escape hatches so that people can cover their own. And I mean, there's stuff like that for using JavaScript. Likewise, if you want to use design pixel perfect, that's not something you can do in the drag and drop designer. You can't change everything there. So for that, you'll want to use CSS. That's okay. You can drop down to the assets in your application, change the CSS, define a new theme, and then go back into the drag and drop designer, and you can drag and drop things into the HTML and CSS that you've just edited. The trick is always to allow the escape hatch without forcing people to abandon the thing that made the framework useful in the first place. And I mean, I could go on all evening talking about examples of that, but I shan't because there are more questions.
Yep, sounds good. I think that explains really well. Let's see, what's the next one? And I guess that it all works the same for the tables when you want to do the sort, and different formats.
Yes, so there's API documentation for that.
Yeah, sounds good.
I would say that the table system is, I said earlier, it is shaped like Python objects for a reason. It's so that everything you do can be passed from the back to the front. If you decide what you actually want is to be writing complex SQL expressions against some external database, go ahead, knock yourself out. There's no reason you shouldn't. You are using Python. That is what import psycopg2 is for. As always, if you want to use something that has more complexity than the out-of-the-box component, go for it, use it, do it the Python way, and you can still use the rest of Anvil to display your data.
Cool beans. So next one is it possible to share any working machine learning models deployed on the Anvil to see the power in action?
Oh, absolutely. So there is a hang on. I'm just going to switch to the screen share to show you this. So if you check out let me get OBS playing itself. Screen share. There we go. Okay, so if you go to anvil.works/learn, which is the tutorials section, you scroll down. We've got some guided app builds. And here is an example I particularly enjoy, which is turning a Jupyter Notebook into a web application. So here, what we have is an example where I take a Jupyter Notebook that happens to have an ML model that can tell the difference between dogs and cats. And I create an application. And then I use something called the Anvil uplink, which is a library you can pip install anywhere in the world. And if you use the uplink key for this application, then you can make any Python interpreter anywhere else in the world act like it's part of this application. So in this case, what I do is I pip install that library from where my Jupyter Notebook is, and then I can connect my Jupyter Notebook to my Anvil application, and I can define an anvil.server.callable function in my Jupyter Notebook that invokes my image, so that invokes my model. and I can call that function.
So are you supposed to share the Google tab, or is there something else you would like to share?
I'm terribly sorry. I've just been speaking to an empty thing. So this is why you should always be nervous about impromptu screen sharing. Turning a Jupyter notebook into a web application.
There we go.
Okay, so what you can do is you can find this in the Anvil website under Learn and then Tutorials. And then down here, turning a Jupyter notebook into a web application. There's a video of this, but what you can do is, I'm just going to show you in Anvil. You can, obviously everything here is hosted in the cloud, but you can enable something called the uplink, which is a library you can pip install anywhere in the world. And then if you anvil.server.connect with that key, wherever you are running this Python code acts like it's part of this application. So you can access this application's data tables. You can make a callable function. And so in this video example, you will see I take a Jupyter notebook that, here we are, can already tell the difference between cats and dogs. And I connect it using the uplink to an application. And now I define an anvil.server.callable function in my Jupyter notebook. And then I go into my user interface and anvil.server.call that function from the web. And so if you want to see this in action, you can go to cat or dog.anvil.app, which is being run by a, oh gosh, let's see. Oops. No, I just lost my window again, didn't I? Sorry, classify cat or dog. I really hate OBS sometimes. Sorry about this. Cat or dog. There we go. So what I can do is I'm uploading a file right now from here we go. I've just uploaded an image from my machine and it has gone to the classifier that's running in a Jupyter notebook and returned that it was a cat. So yes, absolutely, I can show you a machine learning model running in the cloud. That's happening right now. And if you want the step-by-step video tutorial of how I did it, just go to the Learn, Tutorials, and then scroll down to Jupyter Notebooks. You can also see using it with DeepNote, which is a cloud-hosted notebook, or from Google Colab.
Well, that is super.
What else you got?
Yeah. So, how would you compare it to Django?
To
Django.
Django.
Yeah.
Okay. So, right. To answer your question, I'm just going to head back to my slides. Okay. So, you remember right at the beginning when I showed you this diagram. Django is an ORM and a web framework. And so Django helps you solve those bottom couple of problems. You still are going to need a JavaScript framework. You're still going to need templating engines. You still need CSS frameworks. You're still mashing all your data into JSON and REST all the way to and from. So Django is, and it is, to be clear, a very good traditional web framework. And because it is in the paradigm of a traditional web framework, it can only help you so much. And you're still stuck with the fact that all of your data is going from database tables to objects to HTTP to client to DOM to pixels to somebody's eyeballs. And Django has all the problems of the ORM, for example. You need to understand Python and SQL and the ORM to make it useful. You have to understand how the framework works, and you still have to understand how HTTP works, and you still need to write all your JavaScript. So Anvil is trying to be something more than just another of these yellow boxes. It is trying to replace the whole thing with Python.
Great. So what else? These are just like jumping around. So how about your experience with translating between Python ASTs to the Java ASTs? Is there, a straightforward grammar mapping or whatever?
Sorry, say it again. The
translating between the Python ASTs to the JavaScript ASTs.
Yes. So to be clear, we are not translating from a Python AST to a JavaScript AST. We are going to a Python AST, and then we are generating JavaScript directly from that. We are extremely grateful that the Sculpt project existed already when we arrived, because my goodness, that is an awful lot of work. The company now contains 2 of the 6 or so maintainers of the Sculpt, and obviously we do a lot of work on it now. But having a basic thing that actually implemented most of it was Python 2.6 back at the time was still very helpful. You can't really. Oh, okay. So there are a couple of different philosophies of how you can translate Python to JavaScript, and there are actually several different projects out there that try to do this. And Sculpt's approach doesn't really preserve much of the shape of the code. The AST of the generated JavaScript will look very, when it's generated by your browser, will look very different from the AST of your Python code. And that's deliberate, because all that extra JavaScript code is actually implementing the Python semantics. Whereas you can get something like transcript, which that compiles Python-ish to JavaScript. And I say ish because the JavaScript it produces looks very much like the Python that went in, which means it's compact, which means it's fast, but you can't use anything too Pythonic. If you start using some of the advanced Python object features or classes, it will fall over, because actually it doesn't behave like Python, it behaves like JavaScript. So you're writing sort of Python syntax and you're getting JavaScript behavior. And that is what you get if you try to make the ASTs match too much. So Sculpt takes a different approach. It tries to match the behavior rather than making the code look like something else.
So it seems like Anvil has an open source runtime. How about developing apps through? So, for example, are we tied to the Anvil Works build and my accounts?
Okay, so you have the option of using the hosted service at Anvil.works, and to be clear, everything I've been doing today is available on our free plan. You won't get no charge now or ever for it. And if you want to develop something with the free plan and then go host it with the open source app server, be my guest. But if you don't want to use our development tools, there is absolutely nothing insisting that you do. So if you go to the GitHub repository, you'll find the documentation on the file format for how you express an Anvil application. Obviously, mostly it's a bunch of .py files. This is a Python app. But the things like the format produced by the drag and drop designer, you can write those user interface files yourself. Nothing wrong with it. The format's all documented. You can create and deploy an Anvil application with just a text editor and the open source runtime, no trouble. You're not forced to use Anvil. Not forced to use our hosted editor.
And how about the hosting? Is there any restrictions to the cloud providers like AWS or
So if there are 2 ways of deploying an Anvil application. Well, 3. I'll get to that. If you are hosting your application using the Anvil.works hosted environment, then we take care of it for you. We happen to run inside AWS, but really that's not a concern of yours. You just write server modules and that Python code executes somewhere. If you need to be opinionated, you need to say, my code needs to be running in GCP in my organization so that I can access my Google resources, well, that's a good opportunity to use the open source app server. So at that point, you build your application in the Anvil editor, and then you git clone it. Every Anvil application is a Git repository, so exporting something from the editor to directory somewhere is just a Git clone operation. You clone it into your GCP instance, and then you run the Anvil app server there. So there's no restrictions to where you can deploy it. It's just a question of if you want to deploy it somewhere that we are not managing, then you are going to have to run the server yourself. We try to make running that server really easy. It comes when you pip install it, it actually comes with a bundled database so that you don't have to set up and run your own database. Obviously, if you want to, you can connect to an existing Postgres, but if you don't, then it already comes out of the box. Likewise, it comes with a reverse proxy embedded. So if you want, you don't need to set up anything special to do HTTPS termination. It just comes up and gets a certificate from Let's Encrypt and serves your application. We really did try as hard as we could to make it as easy as possible. But the fact remains, if you want it to run in a specific location, you're going to have to set up a server, you're going to have to keep it running, you're going to have to keep it updated, you're going to have to manage that part yourself. But if you're up for that challenge, if that's what you need to do, then pip install Anvil app server, go to town.
So another question is the front end developed by Anvil device agnostic?
Yes, it's mobile first. Well, it is mobile compatible and responsive. So if you go into any of the UI elements in Anvil, you can control sort of how they collapse on small screens. It's the easiest way to do it. So you can absolutely create applications that work just as well on a high-resolution computer or on a phone.
How about does it allow integration with JavaScript CDNs?
Yes, absolutely. So if you go and check out the documentation, I'm going to risk a screen share. Here we go. Yes, it seems to have worked. Goodness me. Okay, so if you check out the Anvil documentation, so that is, sorry, I've just entered the URL. If you go to the Anvil homepage and then you hit docs, and you can go to client code. Hold on, there we go, client code. Using JavaScript. The example they will walk you through, it was a quick start, here we go, is actually loading something like Quill, which is a rich text editor from a CDN. And there is a place in Anvil where you can stick that code. So I could, if I wanted to use a rich text editor in this application, I could go into my native libraries, I could load that into my CDN, and now, now I just need to write a little bit of JavaScript. Write a little bit of Python to interface with that JavaScript library, and I'm away. So let's put a, hold on. Let's put the example on here. And now, there we go. So what we're doing here is we're getting the DOM node from this, for this column panel. We are instantiating the Quill library, which we need to import from the CDN here. There we go, Anvil JS window, import Quill, and then we can instantiate the Quill as if it were a Python object, configure it using Python dictionaries. We point it at the DOM node for this column panel I've just dropped. And now, when I load it, you can see I have a working Quill text editor. And yes, that's all using JavaScript CDNs.
Cool, awesome. I think we've bombarded you with enough questions. There are still some more questions, but feel free to stay around and talk to Meredydd later. And also, maybe what's the best way to reach out to you? If
sure. So my I have, of course. There we go. So my email address is on this slide. It is meredydd@anvil.works. You can also find me on Twitter. My username is @Meredydd. Or you can reach out to us to contact@anvil.works if you want to get in touch. And of course, the Anvil Twitter is Anvil_works.
Awesome. So I guess we're good for now.
All right. In which case, thank you ever so much for having me. I am going to hang around just a little bit longer and chat to people in the breakout areas. Although I warn people I'm not going to be around forever because it is currently 3:30 in the morning UK time. And at a certain point, the adrenaline is going to run out and I'm going to fall over. But until that point, I am here to talk. Thank you very much for having me. It's been great.
Awesome. Thank you so much. I almost just quit the event. All right. Yeah. Thanks so much for the wonderful talk and the great demo. It was awesome, and we're thrilled to have you here. And yeah, let's stop on here and wish you all have a good night and or evening, morning, whatever time zone you are. And hopefully I'll see you around next time. So feel free to hang out in the Hangout room. I don't even know what's that called. All right. Have a good night.
All right.